Welcome to Perimeter Institute and the Future of Women in Science Conference. My name is Ana Sofia Barros. My pronouns are she, her, and I'm the Senior Manager of Equity, Diversity, and Inclusion here at Perimeter Institute. I'm very excited to be here with you. You'll be seeing a lot of me today, so just telling you a little bit about myself. I myself have educational background in physics. I originally studied medical physics and then got super excited with physics and realized that what I wanted was to make physics even more inclusive for everyone. So I transitioned my career to equity, diversity, and inclusion, and now I get to do the best of both worlds. I get to create an inclusive environment in a fantastic physics environment. It is tremendously exciting and inspiring to see a room like this filled with young women who are curious about the world, passionate about science, and eager to make important contributions. We also have additional guests watching online through our webcast, including Thorold Secondary School, Women in STEP Club at Albert Campbell Collegiate Institute in Scarborough, Northview Heights Secondary School in Toronto, Union View High School in Markham, James Logan High School in Union City, John Cardinal Schubert High School in Calgary, Prague British International School in the Czech Republic, Grade 9 science classes at Guelph Collegiate Vocational Institute, and Gordonstown School in Scotland. Thank you all for joining us today, here and online. You are future women in science, and this conference is about you and for you. I am eager to hear your comments and questions throughout the session. We're also pleased to welcome Lamar Corporation as the presenting sponsor of this conference. We have an exciting morning ahead. We are honored to have 20 amazing and inspiring women who have followed STEM careers and are here with us today, supporting and contributing to this event. Altogether, they represent over 250 years of work experience in the fields. 250 years of work experience. Although that may make us feel a little bit old, hopefully we'll encourage you to learn as much as they share their stories, to learn how they pursued their paths, and offer your advice and food for thought in your careers ahead. In the next few hours, you have the opportunity to learn as much as you can from the experience of women who have come before you. Much of science, too, involves building on the work done before and learning from the experiences of others. In the spirit of understanding and learning from what has come before, I would also like to acknowledge that we're located on the traditional territory of the Atawandaron, Anishinaabeg, and Haudenosaunee peoples. Perimeter Institute is situated in the Hildman Tract, land promised to 6 nations, which includes 6 miles on each side of Grand River. As a young woman living in Canada, you're impacted by all that has come before, but you also have the opportunity to learn from the experiences and perspectives of truly diverse community. I encourage you to ask questions and remain open to the thoughts, reflections, and wisdom of others while considering your own path for your future. Throughout the morning, we've tried to give you many opportunities to ask questions and talk directly to the speakers, panelists, and mentors. Please make sure you take advantage of this opportunity. Again, this is a day about you, so your participation and questions are central to making this morning a success. We'll just briefly go over how this morning will work. Soon you will hear from 2 of our 3 guest speakers. Each will be followed by an opportunity to ask questions. After the first 2 speakers, we will have a panel discussion. The panelists will discuss their lives as STEM professionals, but most of the discussion will be driven by your questions. Here we will also try to fit in a stretch break to make sure that you have all that blood flowing. And then later we have later after the panel discussion, we will be followed by our final speaker and few question and answer sessions. And then we will say goodbye to our online audience and move to the atrium outside for a speed mentoring session where you will get to see me again. Yay! This is an opportunity to discuss in small groups with women in a variety of STEM professions, and the mentors, including myself, are very excited to share their experiences and also hear yours. So there's clearly a lot ahead of us for today, so let's get started. Firstly, I would like to introduce a friend of mine, a great fantastic scientist, science communicator. She is a rock star. I'll be inviting my colleague, Celina Guy, So Celina Guy is a Toronto-based ecologist, data scientist, and science communicator. She completed her PhD at the University of Toronto, where she studied bats as carriers of viruses, and now works as a data scientist in Assurance IQ. As a science communicator, Celina spent 10 years working as host at the Ontario Science Centre and has appeared on radio and TV. She has also published her first children's book, Chasing Bats and Tracking Rats, Urban Ecology, Community Science, and How We Share Our Cities, with Anique Press. In her downtime, you can find her in your friendly neighborhood as a friendly neighborhood bat girl chasing her next big outdoor adventure. Please join me in welcoming Celina Guy today. Thank you so much.
Thank you. Good morning. How is everyone doing today? Okay, I'm gonna try that one more time. I know it's early, but the Perimeters put together this fantastic lineup for you today. So how are you all doing today? Fantastic, I love it. So I am really excited to be here today, and as you heard in my introduction, I wear a couple of different hats, right? Data scientist, science communicator, ecologist, and I'll share a secret with you. That's not by design. I did not set out to do any of those things in life, but rather I find myself in this position today because I really struggle making decisions. I don't really know what I want to do for the rest of my career or the rest of my working life. A quick show of hands, how many of you have been asked recently, what you want to be when you grow up or what you want to do one day, okay? How many of you get stressed when... Me too. This question causes me so much stress because there is so much out there to do and explore that I've always found it really hard to say definitively what I will be doing in 5, 10, or 20 years from now. But I do have a very broad kind of path that I've laid out for myself, right? So I am a scientist. I'm a person who asks questions about the world around me, and then I try to go and find answers to those questions to generate new knowledge and new information. And hindsight is always 20/20, but thinking about myself as a kid, it's not really surprising to me that I've ended up as a scientist because I was always curious. I always had questions about the way that the world worked. And I was very fortunate that while my parents aren't scientists or even kind of in STEM-related careers, they found ways to foster my curiosity. And so as kids, this is a photo of me and my two younger brothers. We spent a lot of time at places like the library, the museum. We went to the Ontario Science Centre a lot. And for me, these early experiences helped create this really positive connection between myself and science. I saw science as a way that I could go out and use a tool that I could use to get answers to the questions that I had about the world around me. And for me, this connection was so strong that when I decided to go to university, I said, you know what, I want to keep doing the science thing, so I enrolled in a general science undergraduate degree. Now, to be clear, when I enrolled in that program, I didn't know that I wanted to be a scientist. I didn't know what you had to do to become one. I thought I was going to be a medical doctor. And it wasn't because I wanted to be a doctor or I was interested in that. It was more because I came from a family where folks were not scientists, where one of my parents was an immigrant. And so for them, this idea of being a doctor was a successful career that they could see and they could coach me towards. But when I got to university, this really interesting thing started to happen for me. I had a really hard time sticking to just those courses that kind of good pre-medical students take. I would open up my syllabus and find so much that excited me, and so I ended up not only doing my math and my sciences, but I also took history and classical Latin. My very first research project was actually in medieval studies. And this strategy that I had of each year opening up my syllabus and choosing courses that interested me, but that I could also use towards my science degree, was actually how I found the field of ecology. So I'm a scientist, but I'm an ecologist, right? I'm a type of scientist who asks questions about the natural world, all the other plants, animals, and species that we share this planet with. And my very first research project in ecology was working with these two species of very adorable primates that both live in South America. So this is a golden-headed lion tamarin and the weed's marmoset. And in the last year of my undergraduate degree, I was told, you have to do a research project or you will not graduate. And I was like, okay, well, if I have to do one, I'm going to choose to work in this area, ecology, that I'm really interested in. And so my advisor had dedicated her entire career to studying these two primates. Now, this is a map of South America. Up there in the corner, all of that dark green, that is the Atlantic forest. All right, these two species of monkeys live in the Amazon is up there in the corner. This yellow outline here is the Atlantic forest where these two species of primates live. And more specifically, they live in this tiny little red square down in southern Bahia state in Brazil. And so my job for my research project was to figure out where in that tiny red square was the best remaining habitat for these two species. Because I don't know if you noticed, inside that yellow outline of the Atlantic forest, there's not a lot of green left, right? It's undergone a lot of habitat conversion, it's lost a lot of its trees, and as a result, many of the species who live in this forest, like the golden-headed lion tamarin and the weeds marmosets, are endangered, they're threatened. And so my job was to figure out where in the landscape was the best remaining habitat for these two monkeys so that we could make a recommendation to the Brazilian government so they could protect that habitat, ensuring the success, hopefully, of these primates moving forward. And so to answer this question, where is the best habitat? I didn't get to go to Brazil. I never got to meet these monkeys. I'm still a little sad about that. Okay, but I took all of the data that my advisor had collected throughout her career. I combined that with information from other scientists, and then I used this thing called machine learning. Show hands who's heard that word, maybe artificial intelligence, that's right. So I used these algorithms, the same one that power many of the apps on your smartphone, to identify these best areas in the landscape, and then we handed over those recommendations to the government. Now, when I started this project, I was doing it because I needed to do it to graduate. But as I went through this process of showing up to the lab every day, doing something that no one else had done before me, I fell in love, and I said, whatever this is, I want more of it. And so I decided to enroll in a PhD the following fall after graduating, where I opted to switch gears a little bit and study what I think is simply the best group of animals, bats. Now, in my PhD, I studied bats as carriers of disease. Just like a lot of other wildlife, sometimes diseases may leap from bats into humans. Okay, but not COVID-19, that one wasn't them. You can ask me about it later. And in my PhD, I was focused on trying to understand why and where these jumps occur using two approaches. So I actually went out into the field and I caught bats, I worked with them hands-on, I studied where their populations moved and how their behavior changed when they lived alongside humans. But I also used more of that machine learning to make predictions about global patterns of disease emergence. And I did all of this to help add to the body of information, or that body of knowledge that is aimed at coming up with creative solutions to stopping the spread of these diseases before they even occur. Now, talking about bats as carriers of disease doesn't do a lot for their positive public image, and I don't want all of you to leave here thinking that I opted to study this group because they sometimes share disease with humans. Instead, I want you to leave here knowing that I spent 5 years of my life studying questions or asking questions about bats because they are simply phenomenal animals. I mean, look at this. Bats are mammals like you and I, but unlike every other mammal on this planet, they can fly. And not only can they fly, there's also an incredible number of them all over the world. There are over 1,400 different types or species of bats, and like that diversity, I don't know about you, but this is pretty amazing, right? You've got bats with big ears, long tongues, funny noses. Some, like the Honduran white bat, are, I think, incredibly adorable. It's like a little cotton ball of joy. Others, like the wrinkle-faced bat, it's not the cutest mammal you've ever seen, okay, but it's an important one. Because you see, the wrinkle-faced bat feeds on fruit. And like other species of bat that feed on fruit, it disperses seeds in the landscape, making sure that rainforests continue to grow healthy and strong. Bats who feed on insects act as free pest control for our farmers, and those that feed on nectar are important pollinators, just like bees and butterflies. And so regardless of how you feel about bats, you should thank them, because they provide a lot of really valuable ecosystem services for us as humans. Now, I'm not sure if you can tell, but I really like bats, like a little bit more than the average person. And during my PhD, it was really important that I find ways to help other people appreciate just how amazing this group was. And so as a result, I spent part of my time doing science, but I would also do things like give talks and lead nature walks and do activities with kids showing them the process of how we do science, of how we study bats in the wild. And this wasn't my first kind of exposure to talking to people about science. As you heard in my introduction, I also spent 10 years working at the Ontario Science Centre. For those not familiar, the Ontario Science Centre is the largest, or one of the largest, science and technology museums here in Canada, and I worked as a host. So I would do things like give planetarium presentations, I would run the big silver ball that makes your hair stand on end, the Van de Graaff generator, I would blow bubbles with kids and kids parks. Pretty sweet, I got paid to do this every weekend. And for me, I started working in this job as an undergrad so that I could have a little bit of extra money because things are expensive, but it was how I found this career in science communication, or this job in science communication. I also got to do fun things like appear on TV and radio. These are opportunities that I probably never would have experienced or never would have tried to go out and find for myself had I not worked at the Science Center. And so while I spent, equal parts of my career and most of our time this morning telling you that I do science for a living, I've also spent a lot of time sharing that science with other people, working as a science communicator, which again was a job I didn't know existed until I started working as a host. Now, as I neared the end of my PhD, I was really engaged in the science communication. I really loved my research, but that dreaded question came back. People started asking me again, like, Celina, what are you going to do when you're done? I'm like, I don't know. A lot of people, when they finish a PhD, they will go on to continue to do research and end up as a professor somewhere. But I wasn't really feeling that as a career choice for myself. I didn't want to move around chasing a job, and I recognized that as a Black woman working in ecology, there might be places where there were jobs available that I wasn't comfortable living. And so I sat down and I looked at all the skills that I developed in my PhD and my undergrad, my knowledge of statistics, my ability to code, my communication skills from working at the Science Center, and I started to do a little research. I did some informational interviews with folks. I looked on LinkedIn to see what other kind of jobs people have, and I stumbled on this thing called data science. Data science can mean a lot of different things to a lot of different people, but generally I think of a data scientist as someone who looks through large amounts of information to find opportunities for the organization that they work for. I currently work as a data scientist for Assurance IQ. This is an American tech company in the insurance space. You can kind of think of us as being like Amazon. We're a distribution platform, but for insurance. Now I know what you're thinking. Bats, insurance, yeah, bats are way more exciting, yes, but I still love my job, right? Because every day I come in and I'm being challenged. I'm being asked to do things that I've kind of done before in ecology, but I haven't done before in industry. My coworkers are incredibly smart, so I learn so much from them, and so my curiosity, that thing that is important for me, continues to be fed. I continue to be interested and engaged, but I'm never going to be able to move and separate myself from my bats, from ecology, from the science that started it all for me. And so I look for other ways to kind of stay involved in that. And my most recent project was the release of my first children's nonfiction book. It's all about scientists who study nature in cities. And so moving forward, as I continue to explore this career or this job in data science, I hope to find other opportunities to continue to pursue the things that I'm really passionate and excited about in addition to that work I do every day. And so I've gotten a lot of different places, but if there is nothing else that you remember from our time today, I hope that you will remember that bats are simply phenomenal and you should want to study them. But in all seriousness, I do hope you remember that while it is fantastic if you know exactly what you want to do next, good for you, there are those people out there, that's fantastic. It's also okay to not know. And for me, that not knowing has been the way that I have discovered some of the jobs that I have today, because I've been open to and willing to explore new opportunities that have come my way. And so regardless of what may be next for you, I hope that you will continue to chase the things that you find most interested, stay open to those opportunities, and hopefully you'll be able to discover some things that you maybe didn't know existed. Thank you.
Thank you so much.
Oh, I got an extra slide in there. Go.
She is a scientist.
I am a scientist.
So now, we open the question for questions for Celina. I have so many questions for you, but I also know you from outside,
That's
so
true.
we get
We
to
can
connect.
talk later.
Any questions from anyone? Don't run too fast, please.
I know there's a little time. We got to make it to the mic. Just got to get over people.
Okay, wonderful. Thank you.
As you moved through post-secondary, what was it like to kind of switch from medical science to ecology and ecology-related sciences?
Yeah, so I kind of did them in tandem. I found that because I had enrolled in this kind of general science undergrad, it allowed for me to do that. And I will say that a lot of the things that are kind of specific to medical sciences, that information kind of translated over to questions that we asked in ecology. Ecology is a very big field, and so I ask questions about whole organisms, so like bats as species, but there are some ecologists who study on a cellular level how different animals adapt to their conditions. And so all of those kind of cell and systems courses you might take in medical sciences, even some of that anatomy can be ported over to this area of study as well. Thank you for that question.
Yes, if you would like to go to the... You.
What would you say are the best methods to study bats? And what are your favorite ones?
My favorite ones, again, because I suffer from indecision and couldn't decide, I loved doing field work. It was really hard, but I loved going out into the field and catching bats. We would put like tiny little radio tags on them, like little bat backpacks, and they would fly off and we could follow them around in the landscape. So I really loved doing that. But I found equal joy in taking data from other researchers, like data that's been collected from all over the world, and combining it with that machine learning using those algorithms. So for me, some people are only field biologists, some people are only statisticians in the lab. I wanted to do a little bit of both. So for me, there was no best method. It was always, what is the best method to get the answer to the question that I feel is most impactful to be answering?
Amazing. Thank you.
Yeah.
Yes.
So I just wanted to say I really liked your story. As of right now, I know I want to go into science, but I don't know what career field. So I was just wondering, like in high school or even in your undergrad, did you ever were you in a situation where you wanted to do something, but like maybe like the salary or like the pay wasn't like what you wanted it to be, and you were like stuck?
Yeah, so I actually, so not so much in my undergrad, but at the end of my PhD, this is what I found with academia, right? This idea of becoming a professor, chasing that job around, it wasn't so much about pay. I think professors are compensated well, but perhaps working as a postdoc, you're not compensated as well. And I was like, this is not for me. And so that was the point at which I said, okay, I'm not willing to personally make this trade-off for the next couple of years and hopefully get that job. And so that was when I sat down and I said, okay, I love this, but I also know I could love something else. And what I love the most is living close to my friends, my family, my partner, the support systems that I have. And so that was the decision that I made at that point. Does that kind of help answer that question? Yeah.
Thank you.
Cool. That was the most polite.
So you mentioned that you're a data scientist and that you answer questions on the daily, but how exactly are you doing that? What does your everyday generally look like?
What is my everyday as a data scientist? That's an excellent question. So I think, as a scientist, we look at the body of knowledge and we say, okay, where are the gaps? For me as a data scientist, I come in and I will often consult with like the leaders in our business, so like the big bosses, as I like to call them, and we have a plan that we need to achieve for the year. And so I will look at all of the data. So for us, the data that we get comes in the form of who's interacting with us on our communications platform. And so we have a set of questions that might be focused around like, how do we get more people to engage with us? Or how do we get the right groups of people to the right agents so that they can buy the products that they need to buy the right products that meets their needs? And so, my day-to-day usually starts with we have this general business plan, and because I'm a lead, I have a team, a group of people that I work with, I kind of set out within our area, what are the questions that we need to answer to help get more people doing the things that we want them to do to meet that business plan? Is that cool? Every day looks a little different.
Hello,
Hello. Okay, so first of all, thank you for the presentation. So how do you balance it all so well, like, considering you are studying your PhD and you are like at the Science Center and you're an author right now and you have your job?
I have fantastic support systems. So when I was an undergrad, I lived, and through most of my PhD, I lived with my parents. I'm very fortunate that I have a great relationship with them, and they supported me. I also looked to find other kind of groups of people, or what I like to think of as my community, who could kind of get me through those hard times, because it's not easy. And they really, having those kind of friends who have different shared interests was one of those ways. And then for me, I time box myself because my brain wanders and I'm sure you can tell, I get distracted. And so for me, the strategy I found most successful getting into like nitty gritty, I sit down and I would kind of allocate those big chunks of time that I knew I have to show up for work at this time, I have to show up for class at this time, I have this meeting at this time. And in those open blocks, I would make a list of kind of the things that I needed to get done. And I would just say, okay, I only have 2 hours for this. And I actually found that to make me more efficient than if I just showed up and I was like, well, I gotta do stuff today. Then my mind wanders, I take longer on tasks than I maybe want to, and so I just I only have an hour for this, I'm gonna sit down and focus on it. Yeah, no problem.
Thank you so much.
No problem, thank you.
So lovely having you here today. Our next speaker is Ghazal Geshnizjani. Is a theoretical and mathematical physicist who was born and raised in the historic city of Isfahan, Iran. Her research interests are tackling different aspects of cosmology, such as investigating initial conditions of the universe and the Big Bang, evolution and fate of the universe, models of dark energy, and corrections to Einstein's theory of relativity. Oh my God. Ghazal also teaches mathematics and physics to undergraduate and graduate students at the University of Waterloo and at Perimeter Institute. Like our first keynote speaker, Ghazal is published children's author. Her book, Bella the Black Hole, is a story of a star that turns into a black hole and is written with astrophysical models and black hole physics in mind. Please join me in welcoming Ghazal.
Hello, everyone. It's so heartwarming to see you all here. It's nothing better than knowing that we have the next generation of women who like science. And I'd like to emphasize, as I guess previous speaker gave that message to you, I hope being a scientist is a career, but thinking like a scientist, scientific thinking, mathematical formulation of things, it's a way of life, I think. And no matter where you end up, I hope you take that with you because it's a very powerful tool. And before I get to my talk, I also like to acknowledge the significance of this day. Not only all the women throughout the history who have fought for women's rights, but also at this very moment, women who are currently fighting for women's rights, specifically women in Afghanistan who were recently barred from education again and fighting for those rights, and women in my homeland, Iran, who've been fighting with their allies in the streets in September for the right to choose their dress. They've been beaten, killed, imprisoned, more recently poisoned in a school. So it's not over. But I'm hopeful for the future. As long as we all stick together, we can fight for these rights. Okay, so with that, I'd like to start my talk. And since I'm a professor and a scientist, I'm going to give you a dose of science specifically about things that we do in this building. Let's see. It's going to be a quick journey back in time, all the way to Big Bang. And just to give you a sense of how my head works and what does it mean to be a theoretical physicist, specifically a cosmologist, which I hope you understand what it is by the end of the talk. I'm a kind of person, like any scientist. Let's see. Okay, this thing's supposed to be very smart. I know. Yeah, but who looks into the nature. That's every scientist's work, that we like to formulate things in the nature, understand the patterns there. In my case, it's a space at largest distance as possible. So therefore, the data comes from telescopes and satellites, and then formulate it in the language that we can understand science, which is the beautiful language of mathematics, and apply the laws of physics there. Okay, let's see if this works. Okay, what do I mean? Let's start from our house, or home, Earth, which we live on, which I hope it remains habitable for a long time to come, and you take care of it better than us. But that's not what I work on when I say space. Obviously, I have to get out of there. Right? So I'm going to get in the spaceship, go out in the space. Further out, it's a solar system, but I won't stop there. I'm going to go further out. It's our galaxy, the Milky Way. Nope, even further out. Our neighboring galaxies, more galaxies shows up. No, further up. More galaxies, billions of galaxies, and you start to zoom out and zoom them out, although I don't think any spaceship can go that far out. Finally, this very nice image starts to emerge, which distribution of all these little bits of galaxies and matter and gas, they look like this web, spider web, which we call the cosmic web. So every energy and matter in the universe is kind of distributed like that. And why do I care about that? Because this is our universe, and I want to know, so this universe on these largest, very, very largest scales, what happens to it as we go to the future, or where did it come from when I go back in time? Okay. So what is my tool? As a physicist, we talk about forces. That's probably what you've seen in high school. The major player on these scales, these distances, is our good old friend gravity, which Newton came up with the theory of gravity back 300 years ago or so. And the one that he described, it's pretty good for describing things that happens on Earth, how things fall in. Earth has a big mass, we have mass, we stick to the Earth, or we can fly a little bit, but we need other ways of getting out there. And his description is actually pretty good, even describing the solar system, and how Earth rotates around the sun, the orbit of the moon. The way I like to think of it, it's the way he describes gravity is kind of like holding hands through forces. Like the Earth is holding sun's hand and is spinning around, and the moon is holding Earth's hand and they're spinning around. Unfortunately, this picture or this description is good for solar system, but not quite good on the distances that I'm interested to know what's happening to the universe. So we need a better theory of gravity. Fortunately, Einstein came up with that one. So he thought completely different from the old picture. He said, well, that picture is good, but if we want to do better and understand things better for very on larger scale and things, or high energies and high masses, we have to come up with a better description. And his idea was that really it's not the question of forces, it's a question of geometry. So he came up with the idea that our space plus time, we have 4 directions, x, y, z, and then time that moves forward to tomorrow or backward to yesterday. They have, similar to a sphere or a triangle, they have a geometry. And that geometry is impacted with what mass or energy you put in there. If I had a sphere and we lived in a 2-dimensional thing, like I put a mass, maybe it makes a dent into it. And now think of it, I cannot visualize a 4-dimensional space-time, but something like that is happening. If I have a sun, it has a large mass, it puts a dent or curve the space-time, so does Earth. So they mitigate and talk to each other through this fabric of geometry, and that can describe the orbit, but even better on much larger scales. Okay, so you can now describe the planets, galaxies, all of that. Now go back to my big picture where what I'm interested, the whole universe. What happens there is that now the geometry, think of it as this, not the cosmic web, but this fabric, geometrical fabric, which holds everything together, described with this picture that Einstein taught us. A space-time geometry, his equations, related to matter and energy on the other side. There are 10 equations, a little bit hard to write down, but gist of it is just these 2 words. OK, so everything is nice. So he wrote down his theory. And then he said, OK, let's see what happens to the universe on these scales if I put these theories and this equation and solve them. There was a problem. Because if we put all of that together, even though things seem to be working on a smaller scales, at those scales there was a problem. And to give you a sense of what was happening, the solution looked like something like this. He thought the universe was like this. All the galaxies are in their position. Everything is distributed nicely static. We have the universe sitting there, stable, static. But then the solution looked more like this, putting a ball on the side of a hill, which we know it's not going to sit there. It's going to fall, right? In our language, it meant that universe couldn't be like that. Things either had to be contracting, getting together, or blowing up, expanding. It couldn't just be sitting there static. Then he said, OK, what do I do with this problem? Artificially, he added a constant into his equation, just a constant number, to make things work. And basically, he made the solutions to his equation look like something like this. So now the galaxies and the clusters of galaxies, everything is sitting there, not moving. So everything's stable, static. But still, people realize, well, that's not good enough, because we're talking about the history of the universe. How could you put a ball on the top of a hill and leave it there forever, billions of years? A small, shaking would make this ball fall in either on that side, right, or this side. That solution is not good. It's not stable. It's not possible for all these years or billions of the year universe standing there. That doesn't work. So the problem wasn't solved. The good news was the people who do experiment and observation came along, like Edwin Hubble. They looked at how actual galaxies are moving in the universe or not moving in the universe, and around, I think, at the same time, Edwin Hubble discovered that it's not actually true that the universe is static and everything is sitting there. In fact, if you look into the space, the further away you look, you see that galaxies are moving away from us, and the ones that are further and further are moving faster and faster from us. So that picture is not right. The universe is expanding. So that was a big discovery. So there is maybe no problem with Einstein gravity in the first place. And then Einstein said, oops, sorry, I made a mistake. I should get rid of that constant. I should never have put it there. Let's get rid of it. Now, the funny twist of history is, just about 20 years ago, to me it's just yesterday, when I was a graduate student, again, the astronomers and astrophysicists came back with us with new data and said, you know what? We told you the expansion working, the equations are working. Now there is something a little bit interesting happening. Not only the galaxies are moving away from us, they're speeding up their movement. It's like they're pushing the pedal, gas, and they're faster, making it faster and faster. So there's an acceleration also happening. And I'm like, oh gosh, what do we do with that? Guess what? Did I have it? Oops. Yeah, we had to add the constant back in. Oops, I don't know, maybe I lost the pen. So the question is, one of now, the resolution might be that we have to bring back the constant. Einstein thought it was a mistake. And this is the puzzle we call often dark energy. So either we have to bring that constant back, or there is something else going on in the universe that is causing this acceleration. Now, it is worth noting, I keep saying Einstein, 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 but science is not just work of one person. We put him there, give him most of the credit. But even the Einstein theory of gravity was work of many scientists, thinking mathematicians, to put it together and formulate it nicely. And it's worth noting, one important person, mathematician, Amy Noether, she managed to resolve a lot of problems with the theory. She formulated it in a much nicer, beautiful way. So that's one person who gets a lot of credit on that. The other person I like to mention is Vera Rubin, who also realized even putting everything together, there are still some missing matter in the universe. Even at the scale of galaxies, it looks like when we describe the orbits or how things are spinning, there seems to be some other matter that we don't seem to see it, which is called dark matter. And it is actually the other big puzzle in cosmology that today we think about, dark matter. OK, so let's go back on my journey back to the Big Bang. So now I told you we settled the question of universe is expanding. So I'm going to make you a very quick reasoning why we do believe in Big Bang. And I know sometimes it can be controversial. Why do scientists bring up these big notions? How do they know that? So let's give you a very simple explanation why we do think Big Bang existed. So let's take a piece of the universe, like this square. I'm telling you it's expanding today. Now I'm going to put the movie backwards, go back in time. So this particular piece of the universe would be smaller, so galaxies would be closer to each other. Go back in time, becomes smaller and smaller. At some point, the galaxies even didn't exist. The stars were forming, but things are starting to get cramped up in this piece that I cut out, right? And you can go way, way, way back when it was very, very tiny because it's expanding. So going back, it becomes smaller and smaller, smaller. And at some point, things get so cramped up that they get really, really hot. What I expect. If you push energy and matter together, they start to get really hot. So then the atom couldn't just be there. They would get broken up, the nuclear, the electron and positron. So protons, everything starts to get like a plasma. Even light gets trapped there. It becomes very, really, really hot. And that's what I call the Big Bang era. As simple as that. It was a phase of the universe where no molecule could exist on its own independently. Everything became a very, very hot soup. So it just didn't happen in the piece that I cut out. It must have happened everywhere. If I put the movie backward, everywhere in the universe was in that phase. And that's what we call Big Bang. Now, good news is with Einstein theories, Einstein equation, I can calculate the time that it took from that point in time to today, all the way. And that's how I calculate the age of the universe from that point. It's 14 billion years. Now, you might say, well, you gave me a story. How do you prove that? And that's another job of scientists. If we come up with a conjecture, we have to prove it. The good news is we have a prediction. I say, well, if there was a phase of universe, which was this hot soup, and light was trapped, it couldn't get out. As the universe cools down, finally the light, the photons, get freed. And there should be a reminiscence of that radiation that while the universe evolved and things formed, still it's remained somewhere. It should be a very, very, very cold radiation background everywhere in the space. Is there evidence for that? Can we detect? If we do, that's the image of Big Bang. And let's see. In 1960s, these two guys accidentally they were radio astronomers checking their dishes in Philadelphia Bell Lab, Penzias and Wilson, and they saw there was this very low noise everywhere in the space with very low temperature. At first, they thought, oh, it must be that we didn't clean the dishes very well. Maybe they're pigeon droppings. We have to clean them up. Nope, that didn't. Guess what? They stumbled on a Nobel Prize because they talked to cosmologists and they said, oh, wait, are you seeing the image of maybe this is the radiation we were looking for from Big Bang? It was exactly everywhere in the space, a reminiscence of that background radiation that was remaining all the way from that era, and they were detecting it. Now, good news is, I'm gonna go back, since then, we have progressed quite a lot. This is the image of the radiation they were looking, very uniformly everywhere in space. This is, if you know about Kelvin, this is around very cold, 2.7 degrees of Kelvin. Now, not only we observe that with the evolution of satellites, we have made it much more precision measurement of that image of the Big Bang. So Kobe, WMAP, and today Planck, that we see that uniform radiation, we measure in 1 in 10,000 changes on the temperature of that radiation. That's how accurate and precise our measurements have become. And then we go and analyze this data to see what else happened before that era. And like this is the statistical things that, for example, depending on where, when we draw the points of how these fluctuations happen, when could have been, like what happened before the Big Bang, was it accelerating, something else? So this data tells us all of those stories. And I want to bring up another pioneer woman in cosmology, Hiranya Paris, a good friend of mine, who was one of the people who managed to turn this information, this amazing data, into actual information about cosmology. She actually just recently was appointed as a professor at the University of Cambridge. She's a director of a cosmology center in Stockholm as well. Okay, so I think I'm probably out of time. I'm going to just leave you with this big picture of what we do in cosmology. I gave you the history of, we look into the evolution of the universe from very early time to today, where we make our observation with like a satellite, and what happened to all the content of the universe throughout this history. The big questions that remain, and I work on a lot, is that what happened at very, very first moment, whether we have the quantum regime in that era of the universe or something else. Maybe the universe was contracting before it started expanding. The dark matter that Vera Rubin discovered, the matter that is missing. We are looking into understanding what could be this invisible matter, that it's there, but we don't see it. Or is there something else happening? And finally, this acceleration phase of the universe. Expansion seemed to be speeding up. What could explain that? Is it the old friend of Einstein that he thought he made a mistake, the constant? Is it something else? It seems to be either way. We are stumbled on different problem to explain that. And we have more experiments and observation going as of this year. For example, another satellite is going up, Euclid, who will hopefully shed light on some of these puzzles for us. Okay, and I end with that.
Thank you so, so much. Now,
That's okay. I think I am going to skip that.
now, any questions? Yes, so excited too. Love this.
Hello.
My name is Madeline. I was just wondering, so given that black holes have a soft hair charge, what kind of quantum effects will happen within the actual black hole itself? If the soft hair charge is what differentiates black holes from each other, what's actually going on inside the black hole itself?
It's a very good question. We don't know. We do think quantum effects are going to be important when you get, because black holes are basically another regime where Einstein gravity becomes very important, but at the same time, we do think quantum effects could become important as well. And this is, I didn't talk in this talk because we don't have enough time, but there is a puzzle in our understanding of gravity and quantum theory. We still do not have a theory that describes them both at the same time. A lot of people in this building are working on that puzzle. But there are some ideas that maybe quantum effect becomes important as you get close to the horizon of the black hole. And in fact, there is now new observations. We are observing stellar black holes and the gravitational waves that come out of it. We might be able to see something through that and come up, but we don't have an answer as of yet.
Thank you.
No problem.
And just in the interest of time, we'll have time for one more question. So one question. Okay, wonderful. Thank you.
Hello. I was wondering what kind of degree or post-secondary education you took to go into cosmology and astrophysics?
Mm-hmm. So my background was physics, and then same thing in PhD in physics. But it varies from program to program. For example, in Canada, you could even be doing a mathematical physics under the math degree, or you can be in a physics program. Both often works, yeah.
Thank you.
Thank you so much, Ghazal. That was a fantastic presentation. Oh, we can take one more question, actually. I have time for one more question. Sure. Yes, we have a volunteer. Lovely.
Hi, I'm Elisa, and I was wondering what are the challenges that you face every day in
What's
cosmology?
that?
What are the challenges that you face in cosmology?
What are the challenges?
Yeah, exactly.
Oh, from science point of view?
Yeah, I would say research or, yeah.
Okay, so scientifically, you're asking about the science itself, right? Yes, okay. So one challenge, for example, is cosmology, unlike a lot of other physics experiments that we do, is like an archaeology. So we only have one universe and one history of it. I cannot go back in the lab and produce another universe to see what would happen if I change things. So sometimes that can be a very big challenge because we dig up the history, and this is, I think, the same in history in general, right? You can not go back and change your theory and see if your theory is completely correct or not. So it's a lot of, like, when you make a prediction, sometimes it's hard to prove it back. But yeah, that's one challenge, big challenge.
Yeah, thank you.
No problem.
Thank you so much. Oh, apparently, we have time for one more. Oh my God, just kidding. We wanted to see if you wanted a workout in the meantime. Sorry about that. Yeah, one more question. Wonderful. Okay, one more.
Hi. I don't know much about cosmology, but I have a budding interest in it. And I was wondering, you mentioned the Big Bang started the universe, and I was reading about what might have happened before the Big Bang, and some scientists postulated that it might have been a series of Big Bangs. What do you think happened before it?
It's a very good question, but very hard question. For example, there are ideas, as you mentioned, the cyclic universes, that maybe universe went through these cycles of Big Bang universe, Big Bang universe. That's one idea. The other one, like, my own, like, one of the things that I really work is that, because going back in time, and I don't have the slide, as you see, things start to get really, really small. And one of the big issues, at some point, we get such a high temperature, high energies, high dense curvatures in time that the matter starts to break down. And we don't have a description for that. That's one of our biggest puzzles. So that cyclic idea that you say might be a resolution. But even a smaller thing, even my idea is that maybe universe was just went through one cycle, contracted, but stopped at some small distances and then bounced off. We call them bouncing universes. Now, how to make it work? Einstein theory is not enough. We have to make some correction. That's why,
other quantum theories.
Yeah, exactly. Quantum theories and some modifications of general relativity that's become important.
I just have one more addition to the question. Do you think the future of string theory relies it to work with Einstein's theory of relativity? Because when you use the correct math in string theory, Einstein's relativity equations pop out. Do you think that's a coincidence, or is there relationships between both levels of thinking?
So a string theory is one resolution. Again, we have people who do that. We do have other approaches that might resolve the issue. But nevertheless, we know Einstein theory, like the same way that Newtonian theory was not enough, Einstein theory is not enough. We have a bigger theory. It's just what it is, whether it's a string theory, or whether it's loop quantum gravity or another description. You know as much as I do. We have quite a lot of people working, and I'm hoping I see in my lifetime some resolution to it, which way it is. But yeah, I cannot say for sure. We know the answer yet.
Thank you so much.
And those are the wonders of the work that happens here at Perimeter, which is so exciting. We actually have time for a couple more questions if anyone has more questions. Yes. Oh, okay, yes. We were kidding all along. We had all the time.
Okay, good to know.
My question was, I know this field is like constantly changing. There's always like new data coming. So how is it like working in this constantly changing field?
Oh, it's very exciting. Some of them, I'm actually a more conservative person. I don't try to put my hopes too high because I don't want them to be crushed. But one thing that I can tell you was the detection of gravitational waves, for example. So for a long time, since again Einstein, we knew that the description that I gave you, the geometrical description, one of the consequences is that you can produce waves in it. Because with Newtonian gravity for holding hands, there's no wave. But once you have geometry, it's like a surface of the liquid. I put a mass in it, I do like 2 masses moving, then I expect waves to propagate too, like gravitational waves. And so that was there for a long time. It took people quite like 30 years to put the experiments, these big detectors, infrometers in the earth, kilometers, big arms that can measure small changes in the space-time, because if gravitational waves goes through the earth, it just makes things to expand and contract, and you have to differentiate that from all kind of like earth movements, the trucks moving, earthquakes, seismic, all of that, to measure that very precise wave. And I didn't think it would happen in my lifetime. And in 2015, this experiment, these people who put their faith and life into it, measured them. And since then, we have been measuring quite about 100 black holes, sterile black holes that are merging and collapsing to each other. And the waves are coming to us, and we are measuring them. So it can be sometimes when the data finally comes and you see, yes, this is what we expected. And then it's very exciting.
That's great. Thank you.
No problem.
So data seems to be a common term that is very used by scientists. I love this. Yes. Next question.
What is your typical workday like here, and how did you get into this institute?
Oh, so I shouldn't tell you. I mean, depends on the stage of your career. I think the exciting part is when you're a graduate student, even though you have a lot of work, but you're closest to the science itself. As you become, like in my stage, half of the day goes to answering the emails. So that's, there is a lot of like good things. You go to conferences, you talk to scientists all over the world. That's one of the appeals of the work. I have friends almost in every corner of the world, which like you go there, you're in Tokyo, oh, let's look who is here, and then you get to see them and talk science with them. The other thing is we go to, like we have, Perimeter has this advantage. We have a lot of scientists coming through, so you get to hear about their ideas. So throughout the day, it depends on your work. I could be sitting on my desk and doing some calculation by myself. I might be reading someone else's work. I might be talking to another scientist to brainstorm ideas or resolve an issue. And that's for me because I'm more on the theory side. And people who do the instruments or experiments, they may be going to South Pole, or they may be going to Chile to set up the instrument, measure the actual data, and so on. Yeah. Okay.
Hi. So I was wondering, for astronomy, do you always need to get like a graduate degree, or like what are the opportunities for engineers in aerospace?
Oh, there's a lot,
astronomy?
yeah, because as I told, this field, you can see from it. On one hand, we have this technology and people who are building the telescope and satellites, to people who analyze the data, to people who write the mathematics, all the way through. So we do have very good, like people who do engineering and built up our instruments. I know of them, like, that's their job. And they are like, sometimes they are way ahead of the industry. Some of the technologies they develop purely for scientific purposes, later on is caught up in the industry, because their goal is like, we have to measure this faintest light that is coming from 5 billion years ago. What's the best way of setting it up? And so there is from engineering side also, people who go to instrumental astrophysics also have that. And I think this is interesting, even from computational side. We have a couple of experiments coming up. One is, we have people here in this building working on the data. It's called CHIME telescope, for example. Then the other one is SKA, Square Kilometer Array in South Africa, which I think among all scientists, I might be exaggerating, I don't want to, but we have one of the biggest data coming to us among all the science fields, and how do you process that needs a lot of engineering and computational skills, so a lot of effort goes in there as well.
Hi. I was just wondering, when it comes to cosmology, it seems like it's a very big field. So the room, like as was just mentioned with engineering heading into it, all the room there is to specialize in. I was wondering, do you ever get to go to like observatories or anything and actually interact with the equipment?
I don't, but I have friends who do, and I'm like always envious of them, like people who do go to Hawaii a lot, then Chile. Some of the most amazing stories are from the friends who go to South Pole, because South Pole is one of the also good locations to make observations because of the environment effect. And like this story, I mean, some of it, it's just more adventure. I'm not saying they're having fun. It's like, yeah, we get stuck for 6 months there, no contact with anybody, and then we have like day and night all mixed up, but we get to eat like 7,000 calories a day because it's so cold, our bodies are like, so there are these, interesting stories.
Okay, thank you.
No problem.
Thank you so much.
No,
Thank you. This is fantastic. Thank you so much to our speaker. So, right now, we were going to be starting our panel shortly, but in the meantime, I want us to take a break to stretch ourselves. If anyone needs to go to the bathroom, this is your lovely time. Bathrooms would be here through the side. We have 1 minute? 1 minute to start. So everyone, if you can stand up, stretch yourself a little bit. Stretching a little bit. Yes. Stretching a little bit. How long do I give? How long do I give?
1 minute.
Okay.
So do you want to?
And now I'll welcome our lovely panelists if they can start heading to the stage. Hope you all got a good stretch. Okay. This continues to be a time for you to chat with your folks around you. I want you to start thinking, like now, today, you're hearing all these fantastic things. By the end of the day, I want you to think, what are some of the things that you're going to start doing, stop doing, or continue doing as you start thinking about your career forward, as you start brainstorming ideas of what you want for your future if you're interested in a career science. So yeah, very exciting. Just have a few more seconds before we get started. Okay. Thank you so much, everyone. I'm so excited to be back with all of you right now. Just to let you know a little bit about right now's session. So in this session, we're going to be going a little bit deeper in a variety of different careers and paths in STEM. Our panelists will be sharing how they got to where they are here today, telling us about their education, their choices, and what are some of the different things they did along the way. We're very, very fortunate to have shortly four, panelists representing a range of specialties and work experience. You will find them listed in your program, and in just a moment, I will ask them to introduce themselves. So thank you so much for being here today. Very excited to have you here and to be able to chat and hear a little bit about your perspectives. To start the session off, I will be inviting each of the panelists to tell us a little bit about yourselves and your career path. I will be moderating this discussion, but the floor is open to questions. So similar to before, I'll try not to be rushing anyone this time. But if you have any questions, we have our microphone. Feel free to line up in the microphone, and we will be going through the questions. Same as before, questions will be on a line basis, so based on who's lining up is the order that we're going to be going through the questions. The floor is open, as I mentioned, and I strongly recommend that you ask many questions. This is the time and the opportunity for you to do so. Remember, this conference is about you, and I'm pretty sure that your questions are far more interesting than my questions. So please start forming a line if you have any questions at any moment during the introductions. Now, let's start with Shannon. Can you take a few minutes to introduce yourself?
Thank you for having me. My name is Shannon Tomasco. I'm 34 years of age, and I'm not here to talk about science today. I'm actually here to talk about my journey in the skilled trades. So I originally actually went to school for child and youth work, where I found a passion for people. And from this, I worked in a shelter for homeless youth. But sadly, that really wasn't a job that allowed me to thrive. I just survived. And so I had to maintain my college job, which was working in a financial institution with payday loans. It wasn't a job that I picked, nor one that I went home feeling really fulfilled every day. And it was another job that didn't allow me to really thrive. And so it was convenient that at that time, my best friend Maddie, he purchased a home, and he insisted on doing some home renovations himself. Neither of us tradespeople, but with the help of Google, YouTube, all the resources out there, we did a few renovations. We finished a basement, 2 bathrooms, a kitchen. But through this experience, I realized I enjoyed working with my hands. And I took a little moment to reflect and realize I think I could do this as a job. I could do this for an 8-hour shift. I realized that my resume screamed woman, and so I needed to find some things to support that transition into the skilled trades. And I researched some programs, found one through Hamilton. The YWCA had a pre-apprenticeship program to help transition women to the skilled trades. I applied, completed it, and that leads me to where I am today. Third-year electrical apprentice, working out of Hamilton with the local IBEW 105. And so I do a little bit of everything: construction, install, maintenance, and so that's what brings me here today.
Amazing. Thank you so much for sharing, Shannon. Vanessa, anything you'd like to share about yourself?
Sure. Hi, everyone. Sorry, I moved my mic, so I just want to make sure you can hear me. So I came to Canada about 12, 13 years ago from Nigeria. Went to Toronto Metropolitan University, studied chemical engineering there. My program had a mandatory co-op, which was a blessing for me because it allowed me to be able to apply some of the knowledge I was gaining in school before I graduated. And then after I graduated, I was very focused on joining the pharmaceutical industry. Actually, I was curious about oil and gas industry, but right when I graduated in 2016 is when the oil industry went down. And so my second passion was to explore the process involved in pharmaceutical manufacturing. And I joined my first company, the first company I worked for, Apotex, as a compounding technician. It wasn't engineering related yet, but that position I took really helped me gain hands-on experience on manufacturing different liquid dose products, your nasal sprays, your eye drops, sterile and non-sterile liquid products. Worked my way up to the engineering department where I actually got to optimize the process. So most people try and think about what chemical engineers do, and a lot of people are asking for the name to be changed to process engineering because it is mainly working with different processes to take raw materials from one point to the other where you end up with the final product. And that's what I do in pharmaceutical manufacturing, where we're taking the raw materials, different chemicals, passing it through a process, and ending up with the final medication. So I did that at Apotex for different types of process. Think filling, think packaging, think compounding, big mixers, big tanks. And then I moved to vaccine manufacturing. It wasn't COVID vaccine, but other equally important vaccines. Did that for a bit as well, and then moved to my current company where I am right now, Thermo Fisher, which exposed me to solid dose medication. So I wanted to see all the processes involved in pharmaceutical manufacturing, so I moved around to be able to see that. So where I am right now, I optimize the process that makes tablets, solid dose medication, and that's what I do, yeah. Outside of that, I'm very involved in the STEM community, so I'm very happy to be here and very happy to see that there's a lot of outreach still happening.
Amazing. Thank you so much for sharing. And Karen, would you like to share with us about yourself?
Sure. Good morning. It's really a pleasure and a privilege to be with all of these women on the panel and the speakers, and to see all these young faces kind of following up behind and taking interest in STEM. When I was in high school, I really fell in love with biology. And at the time, we were told, if you do what you love, you'll never have to work a day in your life. And I was like, I love biology. That's what I want to do. And I was fascinated by genetics. So I went into university and completed undergrad in biology. And through that time, I really disliked genetics. I do find it fascinating, but not as a career choice for me. I found the labs very repetitive and monotonous, and it just took so much effort to find something really cool. At the end of university, I just was a little bit lost. I didn't really know what to do, and I was one of the people who, I just still don't know what I want to do with my life. But I took some time, and I was introduced to a program at Sir Stamford Fleming College, the ecosystem management program there. I think it may have been renamed at this point. And I really got into ecological restoration while I was there. And I thought, we have this big, beautiful world, and there's so much damage that's been done by previous generations, and there's just so much potential to bring it back. And I really felt passionate about that. It's probably the only thing in my career that I can say I was very passionate about at the time. And from graduating from college, I got my first job on a field crew at a conservation authority. And as we were just talking about, as you go further in your career, the more time you spend at a desk, unfortunately. And so I just adored, when I look back on those years as a field ecologist, doing fish sampling and tree planting and all of those things was wonderful. So I worked for most of my career at conservation authorities. I got into planning, so I was a planning ecologist. I would review development proposals in the Greater Toronto Area, one of the fastest growing areas in Canada. And those proposals were coming fast and furious, and we needed to review them to make sure that they were addressing legislation and meeting expectations, being innovative, and protecting our natural spaces. And I did that for quite a bit of time. And then I got an opportunity to work on a huge restoration project in Mississauga through another conservation authority, where the project is still going on, where they're creating new land in Lake Ontario. So this is a land extension project where they're creating a new conservation authority or conservation area. If you're interested in looking it up, Googling it, it's the Jim Tovey Lakeview Conservation Area, which is still under construction. It was a huge project, and I was brought in as part of the project management team to acquire the permits that we needed and do the ecological pieces, bring the bigger team together and synthesize their input into the project. And as that project and many other projects went on, I realized that I love working in a space where there isn't really a set path before me. I like to work in innovation. And I got another opportunity to move to the municipal sector. And so now I work in climate change and sustainability for Wellington County, which is just east of where we are. It's a rural landscape, so working with our farmers on climate change work. Right now we're focused on transforming our buildings to low energy and low greenhouse gas buildings, both corporately and in the community. We're working on transportation, so like a lot of variety and a lot of space to innovate.
Wonderful. Thank you so much for sharing. Now, I will open this question to break the ice a little bit and start encouraging some of our audience to ask questions as well. But I want to ask to any of you who would like to answer, what do you know that you now, what is it, is there something that you wish you knew back in high school when making your educational and your career choices? Was there anything that you wish you knew back in the day? Yes, Shannon.
In reflection, one of the things that I wish I kind of understood a bit better is barriers to entries and the benefits that they provide. So as a child and youth worker, it was a diploma program, so it was a college program. And when I was applying for jobs, I found myself applying with experience, not a piece of paper. Public service workers, social service workers, psychology majors, psychiatry majors, EAs, TAs, the list goes on the amount of people that I was applying against for jobs. Now, something that's really unique about the skilled trades and that certificate of qualification that you get when you become that qualified journey person is it's a barrier to entry to jobs, which means even somebody who's really experienced, even somebody who has all the skills, cannot apply for that job unless they have the appropriate qualifications and they've gone through the apprenticeship process, which makes your job, you get paid more, and it makes it a lot easier for you to actually obtain that job. And it's so something I wish I kind of reflected back on. You know, is that piece of paper gonna really secure me the job that I want, or is it really just kind of, you know, opening doors, which is great, but doesn't really, you know, increase your wage, all that kind of different things.
Wonderful. Thank you so much for sharing. I'll take a pause right now to actually introduce our fourth panelist. Thank you so much, Fazilat, for being here today. I wonder if you can take a few seconds to introduce yourself to the audience.
Yeah, sure. Hey, I'm Fazilat. I'm a software developer at Microsoft, and I came to Canada in 2009, and it's been a very interesting journey for me, so I'm here to share that, and I'm very grateful to meet all the young kids over here and share this stage with the panelists. Yeah, thank you.
Thank you so much.
Yeah.
So we'll go to the first question. Yes.
Hello. I have two questions, if that's okay. First one's for Karen. I was wondering, how did you figure out that like child and care, like young children work wasn't for you? And then the other one is for, oh, sorry, I meant Sharon. And the other one is for Karen. Is the job you're doing right now something that you love? And how important is that to you?
I think that everything does happen for a reason, and so, you know, when I reflect on my life, I'm really grateful about my experience to become a child and youth worker. It's what brings me here today, what gives me the passion to, you know, reach young people. For me, sadly, you know, I think it was a learning process for myself and not something that I wanted to do long term, and really just in that industry, it's one of those industries where it's not a job that you can really thrive on. And in the GTA, you know, with growing increases of costs of our rent and different things, I realized it was, you know, I had to consider what was going to also pay well. And so I had to make a change to something definitely more profitable.
Thank you so much. And Karen?
Yeah, so I think the question was, am I enjoying the job that I have now? Yeah, I think it's funny, most people don't think of municipalities as being innovative, and yet they really are when it comes to climate change work. We're exploring areas of legislation and jurisdiction that we haven't used much in the past or used in the way that we are. So there's a lot of exciting work to be done in that space. I think I was kind of born and bred for public service, and so I've always worked in the public sector, and that's really important to me. So it really does check a lot of boxes for me right now, but I am always kind of looking at what is the next step in this journey and what is going to interest me next, and you never know when those opportunities are going to pop up. Like Shen said, that you know, everything is a learning opportunity, and as we learn, even, you know, when you're further along in your career, there's still those opportunities to learn and to pivot and reflect back on, is this serving me well for where I am, and what are my interests and how are they changing? So it's constantly evolving, but I love what I do right now, and I have a great team, and my colleagues in this space are really fun to work with too.
Thank you so much. Next question. Yes.
Hello. This is mainly a question for Vanessa. What kind of technologies for future medications do you believe will incorporate quantum mechanics, particle physics, or nuclear physics?
Well, that's a really good question. I can't really talk much about the science aspect of things because I'm very technical and engineering related, and that's kind of how I move through the work I do. But I think it's good to note that what's taking over every industry is automation, AI, Industry 4.0. There's going to be a continuous need to keep on evolving the technology in manufacturing in general. And that's one of the biggest changes that I do see happening. It's going to be a slow process because it's hard. The turnover of getting those new equipment, starting it up, it's going to tank the businesses if they all move towards doing that change right now. So it's going to be a slow progression, but it's something that I see is in the forefront for all manufacturing industries, where they're trying to see how they can move with the future and really utilize a lot of the technology that's come out in the past decade. With AI, the machine learning that was mentioned. So all those things are being infused into the conversation right now in manufacturing.
Thank you. And from the physics perspective, because that's actually what my background is in, I can share a little bit about that. From the physics perspective, I actually studied medical physics, and my research was originally on radiation therapies and trying to visualize cancer tumors at the same time that you're treating it. Some of the things that I can tell you is that, for example, medical physics as a field is the use of physics and physics ideas into medicine. So thinking about radiation, thinking about medical imaging, thinking about dosimetry and different ways that you can treat different diseases with physics is actually a huge, huge field nowadays. So I strongly encourage you to look more into that if that's something you're interested in.
That's immensely interesting. If you don't mind, I have another question semi-related to that. Using those technologies, degrees of freedom come with like almost everything in physics. How do you incorporate those degrees of freedom and work around them using medical technologies?
Degrees of freedom in terms of?
In terms of, so when you have an uncertainty charge within an equation per se, you had to add a degree of freedom, right? How would you incorporate that within medicine? Would you have to ignore that, or would you have to kind of work with them?
Yeah, so that's actually quite an interesting question. So from my end, at least with the research that I did, a big part of what I did was simulations. So before we even go into thinking about treating a patient, we try to find different ways to see if our physics is feasible and what the likelihood and what the, as you mentioned, like the sources of error potentially could be. So all of my research was actually all computational simulations, where I created a facility, a proton therapy facility. So we're trying to see if with protons we know that with protons we can treat certain types of cancer. So visualizing that and seeing how at the same time as I'm treating the tumor, if I'm being able to see or visualize what I'm treating. And that visualization can help you start understanding whether if you're treating something right away, if there's any sort of potential of, when it comes to radiation, going to other parts of the body, for example. So again, using simulations is a great way for us to understand a little bit more what the likelihood of any sort of additional radiation can look like and what sort of concerns could be if we were to go to a patient, for example. So that's a great way that we start. And then we start going into what we call phantoms, or different similar to tissue materials that can help us see how we would potentially behave in tissue. So all of those pre-experiments, if you can call them, can help you and guide understanding what that uncertainty can look like.
Thank you so much.
No worries. Next question.
Hello, ladies. My name is Tia, and my question for you is, how, as women in science, what was your experience like, and have you faced any diversity, and how did you push through that?
I can speak as a woman in engineering. I think you get used to being the minority in the room just from university. There were a lot of classes and labs that I found difficult because either I was the only woman there or I was the only Black person there. But that was then, and I see a lot of change happening. So I'm very happy with that part of it, but there's still so much work to be done. How I navigate it is just trying to focus on the good part. There are a lot of allies, there are a lot of people within the spaces that I've been in who are always willing to lift me up or to pull me in, who are very conscious of my position in the spaces that I occupy. So I think I lean more into into taking those opportunities and utilizing those resources.
Yeah, that's great. Thank you.
No problem.
Yeah, I would like to share a little bit different experience that I had is I came from Bangladesh, and in Asian countries, maybe most of you already say that Asian parents are always very keen for their kids' education. So in our country, at least in middle-class families, you can get only two jobs. Like either you wanted to be a doctor or either you wanted to be an engineer. Okay, I came to a society where I didn't see there was a minority in women. I would say that they are not taking the path for engineering. They are not taking the path for doctor. So I had a very good experience where I see that a lot of other girls are also in the engineering. So that made my path really easy for me to choose, okay, I can be a doctor or I can be an engineer. It's more like the society which drove me that path, I would say. So I was a little bit lucky in that manner. So going forward, I didn't have that mindset that, oh, I have to be scared because I'm going to an engineering route or I am going to a doctor route or something like that. I was like, okay, I like this like computer science or programming, so I can go towards that and I can achieve my dream. So just wanted to share that. Yeah.
Thank you so much. In construction, I find it's been challenging because there really is still predominantly, it's a male environment out there. And so for me, a lot of times, when you're having a day where you're feeling a little, alone or like you are the minority, there's so many community resources out there, groups that are on Instagram, Facebook, Women on Site, Build a Dream. These kinds of organizations really allow women to gather in numbers when you might not actually see them out in sight. And so it's really, I think, crucial to talk about that support system, to have that support system, have people who might be experiencing similar things, and so to reach out if they're not necessarily on your construction site, because they're still few and far between.
And one of the things that I can tell you as the Equity, Diversity, and Inclusion Manager at Perimeter is that one of the things, as someone who has worked in this field for nearly 10 years, coming from physics, there has been historically a lack of diversity in the sciences, but there's a lot of efforts that are being put by the government, by different institutions to really advance equity, diversity, and inclusion. So what I recommend to you as youth looking into the future of your careers, if this is something that matters to you, and it should, it's to look into what are the resources that are in institutions you're interested in. I'll give you an example. Here at Perimeter, we have the Inclusive PI platform, which is a platform of a grassroots platform from groups from all over the institute. We have researchers, we have staff, we have students who collaborate in different working groups that help advance inclusion at Perimeter. So we have folks working on anti-racism, on understanding gender in physics, understanding climate change, and how do we bring climate action, and thinking about how as a collective we can be more inclusive and more helping support and create that sense of belonging here. So those are things that can help you as a future scientist to identify if those support systems are there in place for you when you're going into your careers.
That's great information from all of you. Thank you.
If I can just add quickly
Yes.
that what I'm seeing in the fields that I'm working in ecology and in public sector, is there are probably more women than men at the more junior staffing levels. What we're not seeing is those women rise up into senior positions with authority, and it's really an area that we need to work on and break down those barriers.
Yes.
Totally agree with that.
Yeah.
Yeah.
Definitely. Thank you so much. Yes, next question.
Hi, I have a question for Karen. So as you were going into conservation, ecology, and environmental restoration, what kind of steps did you take to get there, and how do you think we could continue to work in those fields to ensure the survival of this planet?
So I almost stumbled upon ecological restoration. My younger brother's best friend's brother took a course and he let me know, and I reached out and we didn't connect. It was kind of a muddled way to get there, but I found Sir Stamford Fleming College in the process and took their ecosystem management program, and that was sort of the first step. It takes quite a bit of field work. I had an old mentor of mine, a former mentor of mine, who said you need to spend more time in the field, and that's one thing, if I had gone back, is to spend more time in the field, out in there, experiencing the environment, observing those interactions that are happening, really understanding all the other disciplines that go into ecological restoration, geomorphologists, hydrogeologists, hydrologists, they're terrestrial ecologists, aquatic ecologists. They're all together, create this really beautiful team that work on restoration projects. And there's different ways you can come at it. So as a field tech, I was doing some hands-on stream restoration, a lot of tree planting, a lot of structure building in rivers, that sort of thing. And then in planning, in my planning role, I was reviewing applications and proposals for stream realignments, fish habitat creation, that sort of thing. And then as a project manager, doing a lot of more desk work, planning, more integration with some of those other disciplines to create the proposals and address the needs for permitting and things like that. So you can come at it from a lot of different ways, and there's a lot of pathways to get into it.
Thank you. Thank you so much. Yes, next question.
So I had a question for Karen. So I'm also, like, similarly to you, interested in biology, and I'm in my last year of high school, so that's like the programs that I've applied to. But what has like pushed you to pursue like ecology, and what would you say like the field work is like?
I never enjoyed ecology when I was in school.
Oh, sorry.
I don't think
ecosystem management.
I don't think it's taught well, to be honest. In my experience, my teachers, it was very textbook, like this is the Arctic, this is the boreal forest, like, and pictures. And you really need to experience ecology, and that's what I loved about going to college. Was it's very practical, it's very hands-on, it's get your hands dirty, come up with a team, work together, try to solve the problems. So I think I really benefited from that experience. It was more in line with the way that I learn well, and it became very real when you're out in the field. So field work, as I'm sure Shannon can probably attest as well, there's a lot of barriers to women in doing field work. You know, even washroom breaks are a challenge in doing field work. You're out there pretty well in any sort of weather. I did a lot of stream restoration, so we were walking around in waders in streams. I was probably the fittest I've ever been in my life doing that work. You eat out in the field, pack a lunch. So that was my experience, but I was in the public sector. It's really kind of a 9-to-5 job. But there's lots of jobs out there that you can be flown into areas, and you're at a camp and you're working not a 9-to-5. You're working, you know, late into the evening. So it really depends on where it is you're wanting to go, what area you want to work in, and what those opportunities are. But the field work is, you make great friends and connections that stay with you for, it's almost like being at camp. It is really some of the best time of your career. So take the time and enjoy that part.
Yeah, thank you.
You're welcome.
Hello everyone, my name is Mahi, and my question goes out to anyone here. So have any of you ever felt burnout, or the feeling that you have too much pressure on you guys and throughout your academic years? And if you have, how have you guys coped with that?
I guess whatever makes you happy, just do that, because you will have those burnout moments, right? Like anywhere, like in university, at work, you will have those burnout moments. But now you need to give yourself a break. We all need to understand what we like just get away from that space and teach your brain to be happy on something, and then come back with a fresh idea. Because as a software engineer, I can tell every single day we are implementing something, we are trying to deliver something. By doing that, sometimes we get into a bottleneck. Okay, nothing is working. all of a sudden, right? But it will work, but you just need to give yourself a break, go for a walk, do exercise, or whatever makes you happy, right? We all have our own something that we like to be happy with, and spend some time, give a break, and then come back with a fresh idea, and then you'll see that everything is back to normal again. That's what I do.
For me, leading engineering projects in pharmaceutical manufacturing is always very high stakes, because usually you're taking the process down so you can implement the changes, and they're not producing at that time, and that's profit, that's loss, it's just a whole ball game. So it's very high pressure. I try to always be very kind to myself. I make a conscious effort to not put myself in a situation where I feel like I am pulling out my hair. I know what to expect with regards to like high pressure, making sure that I get things done in the timeline that we need to get it done at. But I also make a very vocal and conscious effort to my manager and to the people around me when I need a break, when I need to take some time away. I'm always very vocal about asking for support. If I do need some time away, I will ask for that support so that someone can cover for me for a short period of time if need be. But there's always people ready and willing to help you through things. That's what I've realized. I think before it was hard for me to really find my voice when I was new in the industry. But now I've realized there's ways around things, and I'm also someone who's ready to jump in to support other people. So why do I always think people won't jump in to support me, So that's kind of how I've been dealing with it recently.
I think, if I can add, working in climate change is a constant pressure, because you're working on behalf of the planet in a short amount of time, and that can be very weighty. And in small and rural municipalities, which is the County of Wellington, and similar municipalities, there's usually just one of us on staff trying to, I like to think of it as turning a ship around against current. So it can be a lot of pressure. So when I first started this role, I connected with some of my neighboring municipalities and their new climate change staff as well. We connected, we met at least monthly to talk about what we were doing, keep each other motivated, and we still do. 4 years later, we still connect fairly regularly, but it's blossomed into some wonderful partnerships between our municipalities, which has been really, really great and beneficial for all of us. And I think just knowing that there are other people out there who are working on the same thing as you, finding those people and connecting with them and just sharing your experience, because as Vanessa said, there's a lot of support out there that can inspire you. Things like these types of conferences, they'll inspire you and motivate you to keep going. Sometimes you just need to take a breath and step back and then move forward again.
I'd love to add one final thought on that. I think mental health is such an important topic in 2023. We've all experienced a lot of struggles through the last few years. Anxiety, depression, burnout, these are all real things for everybody. Nobody does not experience these things. And I think it's the most important thing you can do for yourself is identifying, being self-aware, being reflective of yourself, taking a moment, am I struggling right now? Is this my norm? And then also learning coping mechanisms for yourself. Are you a walker? Do you like running? Do you like music? Do you like to write? For me, it's meditation. I need to take a moment and clear my mind, to have a clear mindset. And so it's so important. Be aware of how you're feeling and take breaks using coping mechanisms that work for you. We all struggle, and we all have to, reach out to each other, be each other's support systems, and be kind.
Thank you so much for sharing. I think those are all fantastic advice. I agree when it comes to mental health, there's been a lot of work in removing the stigma, and the conversations are being so much more normalized. So I encourage all of you to remember the fact that in an airplane, you have to put your mask on first before you put it on others. You need to take care of yourself first before you take care of anything else. So feel free to do that, once you get into school, there's going to be supports there, both mental health support, student support from the institutions themselves. Use those resources. They are there for you. They're there to help you. So don't feel bad for using them. They're meant for students. So yeah, make sure that you don't feel bad about that. Use it. Take space. That's good.
That's some great advice. Thank you so much, guys.
Thank you. Next question, yes.
Hi there, my name is Sarah, and my question goes out to any one of you. My question was, as young women in STEM, with so many pathways available for us, what kind of suggestions do you have for us to be able to explore the pathways? What do you suggest we do in high school or in post-secondary to kind of see what's out there and be able to experience all that you guys have talked about?
I'm all over this question. So I so think it's important. You know, you guys are all here discovering. Like, the most beneficial thing you could do for yourself is to educate yourself, to empower yourself, to make what feels like a lifetime decision. But don't forget to be fluid, to be flexible. While you're in high school, you guys have the opportunities to try free things, to try things like OEAP. If you have not taken a look at your local high school's OEAP program, SHSM is throughout Ontario. These programs are your co-ops. That's when you get to go out and actually experience, you know, a job, a trade, whatever it might be, at free cost. As soon as you step into college or university, you're paying somebody for that experience just to try something. And like myself and so many other people, we sign up for that first year of college or university, and perhaps we realized maybe that's not for me. Try it while you're in high school. Co-ops give you the opportunity to learn skills that are transferable for life. I still remember the kid, and when I was in school, Ian, he went and worked at the local butcher shop. And I think about Ian every time I go to Costco and I look at the big chunk of meat and I'm like, well, I would love to save some money on this giant cut of meat, but I don't know how to cut it up myself. I myself decided to take drama. It's not saving me money, you know, and giving me future skills. So take advantage of free opportunities. Try things. This is like my biggest takeaway. It is truly an amazing experience if you can find something that you love and find it in a job. But you're only going to know if you like something if you try it. And if you don't get out and experience the world and you only live your life through your cell phones, social media, you will never truly know if you love something or not. You have to try it.
But speaking of cell phones, the internet is amazing for sparking curiosity. Stay curious. Everything you're saying is correct. But also utilize your technology in the best way. When I was going through my engineering program, I was always looking for answers because I'm the first person in my family to do engineering. I just felt like I didn't have anyone to look to ask questions. And so I found YouTube, and I went through every single video I could find on YouTube, and it even inspired me to start my own YouTube channel after I left school to tell everybody about my journey and how I was able to navigate things. So go and use whatever's out there already. Google, YouTube, networking. The world is your oyster. Just be curious, try new things. Even if you're not too sure about certain things, just try it out, and then you get a more informed decision on whether or not you want to explore things further. So I think just stay curious. Stay curious about everything until you figure out. You won't really ever really figure out things like hard line, but just be curious and you'll find better paths.
Thank you very much.
Also, think about transferable skills. Celina talked a lot about that. Think about the fact that any career you go into, you're gonna get likely some transferable skills. So that's one of the great advantages of science. Yeah, so we have time for one more question.
Hello. So I have a question for Karen. Considering climate change is moving at like such a fast pace, do you think we could ever like stop it or possibly slow it down? And if so, what are some ways we can do it like on a larger scale, like country, like by a country or like worldwide?
Yeah, I think I still have hope that we can slow it down, keep it to 1.5. And I know there's a big community out there working around the clock to try to find those ways to do it. The federal government has, in Canada, has come out with some huge programs recently that are supporting industry, they're supporting other government programs, homeowners, drivers to change what we're doing, and that gives me hope. And I know there's always critics to everything we do. Like, why didn't you do it this way? Why didn't we do it this way? I think we just have to do things. We won't get it perfect the first time, but we're working towards those perfect solutions, and we just have to keep moving forward. So things you can do, be mindful of the decisions that you make. Is probably up there, along with talking about it. The more we normalize climate change action, but the more it becomes part of everything that we do, the faster we're going to get there. So talk about it with your classmates, talk about it with your friends, talk about it with your family, ask questions, investigate, and the more people know, the more action will be taken.
So it can't really be stopped at this point?
Pardon me?
It
Can we
can't
stop
really be
climate
stopped,
change?
yeah.
That's a hard question. It is a hard question. I don't know that we can stop it completely. What we want to do is throttle it back a lot. And so, keeping it in that 1.5, that's what we're aiming for. We need to get there very quickly. And I'm hopeful that we are going to come up with some net zero greenhouse gas emissions solutions. And the more we do that, the closer we are to stopping it. Can we actually stop it? I think that's a question for some other scientists to deliberate.
Okay, thank you.
Thank you so much to our panelists. It's fantastic hearing all of your thoughts, perspectives, experiences today. Even though we did not get to go through all of the questions, you might get a chance to speak to some of the panelists at the end. Some of them will be outside in the atrium during our speed mentoring. So if you have any additional questions, you might be able to ask them there. In the meantime, I would like to welcome a huge applause for our panelists. Thank you so much for your fantastic.
So much. So we will be moving forward. So we will invite you. Oh, thank you so much. We will be moving forward right now to our next speaker. Our final speaker is Melanie Anderson. She is the Director of Cryptographic Security and Systems Development, part of the Canadian Centre for Cybersecurity at the Communication Security Establishment. Melanie is an executive champion of the Women in Cyber and Intelligence group at CSE and is passionate about mentoring, promoting the well-being and interest of women and encouraging girls and young women to pursue careers in STEM. In addition to her career in information technology, Melanie is an avid singer, ooh, amazing, and musician. We'll see if we get some music. She performs locally as a professional opera singer and spent many years teaching piano and voice. Please join me in welcoming Melanie Anderson. Thank you so much.
Thank you. Good morning, everyone. Wow, it is such an honor and a pleasure to be here today. I'm going to do super old school and not actually use slides. I work in technology every single day, and sometimes I just want to have old school pen and paper. So I am absolutely thrilled to be here today to speak to you all, and I look forward to speaking with many of you after. I'm going to start by saying, I know I'm from the Communication Security Establishment, and for those of you who may have done a bit of research, we're often referred to sometimes as cyber spies. You can ask me anything, and I will answer it to my best of my ability and whatnot. So I'm really honored to be here and to speak with all of you. I'm honored to share the floor with so many amazing women. Being the last speaker is a bit intimidating, I'll be honest. I'll put myself out there and be a little bit vulnerable. Just to be surrounded by so much brilliance, and that includes each and every one of you, is such an honor to be here. And I'd like to just take a moment for you to take this all in. You are here as part of a strong community of female scientists and leaders, and you're trailblazers. So just take a second to take that all in. Each and every one of us bring unique perspective, backgrounds, cultures, and diversity of thought, and we need you in this community. So maybe let's get to know each other a little bit. I know sometimes when I see speakers, it's nice to know a little bit more about them. And so, as was introduced, I love music. I actually grew up, I was on stage from the age of 4. I loved public speaking. I grew up in a really small place, like graduated high school with 40 people, so everybody knew everybody for many, many years. I was lucky that I had the opportunity to participate in a local music festival, and so I did public speaking and I played piano. I went to my local city and I participated in choirs, I did drama club, I did all of those fun things growing up. And I also did sports. So I played basketball from like the age of 4, all small community bred basketball players. And I learned a lot about teamwork and leadership from my experiences playing sports. I was really into math. It's been mentioned so many times about being curious. I loved learning things, and I loved people that challenged me and gave me opportunities to learn about the various sciences, about math. I loved going to music camp. I actually learned to play the oboe one summer because I was like, I've only ever played piano and I didn't have the opportunity to participate in band, so hey, I'm gonna learn how to play the oboe, and it was super fun. I also grew up on a farm, and I had a lot of animals around me, so we've talked about nature and the ecosystem that we live in, and that's something that actually, when we talk about balance, keeps me grounded. I have 2 special needs cats and a corgi puppy that I just got this summer, and they keep me busy. They keep me on time to get home to feed them pills, and I feel it is a privilege to have animals around us. And I'm going to be super interested in looking at more about bats after Celina's talk. I also, even though I work in IT and I work for the federal government, I was lucky enough that I was able to take time to pursue my passion of singing. So I spent 3 summers in Italy where I honed my craft, and I was able to learn from experienced professionals, and I actually debuted a role with orchestra in Italy back in 2016. And all of those experiences have brought me to where I am today, and so I am very grateful for all of those opportunities. And I encourage each and every one of you to think about what lights a fire within you and follow that. That's really important. And so before I get into a little bit more about my career, I just wanted to share a little bit about the Canadian Centre for Cybersecurity, where I work, and what we do. So we are Canada's technical authority for cybersecurity. How many of you have phones? Okay, I don't think I didn't see a hand go up. Cybersecurity is everywhere. Anything that you use that's technology-based, that connects to the internet, it could be your refrigerator at home, it could be your cell phone, it could be a computer that you use, a tablet. Everything that we use to connect online today is cybersecurity. And so our organization provides advice and guidance, services and support for Canadians and Canadian organizations. We collaborate. Cybersecurity is a massive field, and it is a team sport. We cannot do it alone. So we work very closely with other government departments, with critical infrastructure, so think telecommunications providers, banks, hydro, all the things that we depend on and use every single day. And so why do we work in collaboration? Because we need to prepare for, respond to, mitigate and recover from cyber threats. Unfortunately, with opportunity come challenge. And there are lots of folks out there that want to do bad things with technology. And so we have to make sure that we operate in a secure and safe manner. And I'm happy to talk offline about some tips and tricks that I have from a cybersecurity standpoint, but there are a ton of resources out there. We have a campaign called Get Cyber Safe that basically gives you tips and tricks on all the things that you can secure your home router. Talk about passwords. Don't ever use the same password across multiple accounts. I'm just going to put that tip out there right now. And so what we do in the Cyber Center is we help solve the most complex problems that exist in cybersecurity. And we raise the bar to make it difficult for those bad guys so that Canadians can live and work online in a safe manner. The pandemic threw many of us for a loop in terms of how are we going to continue to operate, and it shifted a lot of us to take school courses and to work online. And again, doing that in a way that's safe and secure is really, really important. If you're interested in learning more about cyber threats, we have a lot of publications that we put out. We recently released the National Cyber Threat Assessment update that talks about cybercrime being the #1 threat that Canadians face, many organizations, as well as state-sponsored threats from various regions around the world. Some really cool examples just to give you an idea of the types of things that we do. For example, many of you may have seen on the news that there was a cyber attack against the Newfoundland Labrador healthcare system back in 2022 that impacted their critical IT systems. So it wasn't my team that was there, but my colleagues' teams went out on site to actually help them understand what happened, come back online to ensure that the folks that live in those areas could get the medical attention that they needed. We also have a number of campaigns, and you can see it on social media, on the spreading of misinformation, disinformation, and malinformation, or what we refer to as MDM. Sometimes you may see on social media, there's some like weird posts that show up and you're like, that looks really odd. The font might be a little bit different. You're like, where did that come from? There was actually a campaign that Russia had against Canada that used pictures of the Canadian forces, and they had a narrative about how Canadians were committing war crimes in the Ukraine and using those fake images. And so in response to that, the Canadian Centre for Cybersecurity put out some publications on how to spot that information, which again is educate yourself. This stuff is really important to understand so that you can be critical when you're looking at information and understand if it's real or if somebody is trying to make you believe something that isn't true. And so as I mentioned before, a lot of this stuff is on our website, cyber.gc.ca. There's a ton of publications on every type of technology that you could imagine. Get cyber safe, and you can follow our social media channels. I'm also on Twitter, and I promote some things from time to time. But let's get back to my career, and just to give you an idea, like many of the speakers today, I didn't really know what I wanted to do. I think back to Celina's talk, and I was good at math. I was singing, and I actually was like interviewing to go into classical music programs. And then I was like, well, I'm really good at math. And at the time, they were hiring women into computer science. And so I'm very grateful because I did my Bachelor of Computer Science at the University of New Brunswick. I'm from the East Coast. And it was an hour away from where I grew up, so I moved to the big city of Fredericton. For any of you who have been to Fredericton, you know it's not a super big city, especially when you compare it to Toronto or Montreal. My dean was a woman, and her name was Jane Fritz, and I am still in touch with her today. And the impact that she had on me, she brought me into a lot of these women in STEM events, and I am so grateful for that. I did a co-op program in my university degree where I got to work in a power plant and participate in e-learning companies and how they actually delivered courses online, which was super cool. Then I did a co-op at CSE, and the rest is history. I've been there for 20 plus years. I started as a software developer. I was dumpster diving in hex code, trying to figure out what the data was that I was looking at to make it useful and relevant. I like to organize information and break it into chunks. And so I minored in databases, thought that was super cool. But I've always been a people person, and I love leadership, and I love bringing people together and making sure that people have what they need to succeed. And so when the organization decided to send me to the National Security Agency in the States as a technical liaison representing Canada in a Five Eyes office, I was like, you've got the wrong person. Me from small town New Brunswick, like, I'm not gonna be able to do this. And I remember talking to my partner at the time, and I was kind of freaking out. Like, they're sending me on behalf of Canada to like this big building in this like super scary spy place that's on TV. And so I remember just being like, wow, this is a huge opportunity. And I was scared. I was so scared. I remember walking into a boardroom, and I was the only woman, and there were 40 men, probably all over the age of 50, sitting around the table talking about, I think we were talking about like data structures or how information was being shared. And I was like, again, I'm not here. And somebody said, who let the girl in the room? And at the time, I had the opportunity to let that get to me. or to let it slide off and be like, that's all right. And I was like, who are you talking about? Haha, nice to meet you. And I just jumped in, and I was bold, even though, yes, it did sting a little bit, but I learned from it. And I was able to continue building my reputation as a technical expert from Canada, participating and contributing to the global cybersecurity industry. I also, then when I came back, I worked in cybersecurity incident management. So anytime you see those cyber threats that pop up on the news, the Canadian Centre for Cybersecurity is there for anything that happens in Canada, and a lot of it is not made public. It happens every single day. And the international collaboration that I've been able to be part of has been a huge, huge influence in why I'm still in this industry. I've got to travel to places like New Zealand and Australia. I've met some amazing friends and folks that I still keep in touch with today. And now I'm in crypto. So I'm just gonna say, not a mathematician. Very, very exciting, again, to be here. I lead a team of incredible mathematicians who provide advice and guidance on how to use cryptographic algorithms and protocols. For those of you who may have seen, the government announced the National Quantum Strategy. From here at the Perimeter Institute, my team and I had input into that particular strategy and work with a lot of the folks that were part of that. We're preparing basically Canada for how to respond to the quantum threat to cryptography. So for any of you who maybe use secure banking, all of that is underpinned by public key cryptography. And my team is there to help people understand what they need to do in order to be secure as the threat from quantum computing advances. Things are coming. The world is changing and technology continues to evolve. And so again, I'll go back, not a mathematician, and so when they asked me to step into this role, I was like, are you sure? Did you get the right person? I've had a lot of doubts in my career. But I've always had supportive network of incredible people around me to help nudge me in the places that I needed to go. And I'll share with you, I have a ring that I have that is my Bachelor of Computer Science ring from UNB. And I wear this every single day because sometimes when you're surrounded by brilliance and folks like yourselves, sometimes you need a physical reminder to say, I belong here, and I have a valuable voice and a valuable contribution to this community. And so just to give you an idea, that's something that I really hang on to. And so in my career, again, I've been very, very blessed to be one of the co-executive champions of the Women's Network at CSE. I mentor a ton of incredible young women. I learn as much from them as they learn from me. And we've talked about EDI and the importance of diversity and inclusion. I cannot stress enough how important diversity of thought is and how much we need you in this industry, in science, in STEM careers. So now I'm going to shift a little bit to some advice. So when we talk about things that you wish you knew in high school or things that I've learned along the way, and I just want to share a few of these items with you. And so as both Celina and Vanessa said earlier, be curious. Ask questions. You have every right in every room that you're in and every paper that you read online or every piece of information that you consume to ask questions, to be bold. Put yourself out there. The second is to leverage your community as a network and to help you get through challenges. Every single one of you is going to face a challenge in your life, and many of you probably already have to this point, and you will continue to face challenges in the future. It's important to lean on your support network to get through those challenges. And get a mentor. Get two. I have three, and I mentor lots of different people. You're gonna get different perspectives and thoughts from every single person. And you have, and we're gonna get to the networking session soon, which is very exciting. So take advantage of that. Ask questions, get to know people. The third thing, which is gonna sound a little bit weird, perhaps, is learn to love failing. I used to be the perfectionist. I'm a recovering perfectionist. I said that a lot. I was the super, like, if I didn't get 100% on an exam, I got really upset. When I got to university and I got my first C, I crumbled. I was like, oh my gosh, the world is ending. But you know what? In every time you maybe fail or struggle, it's a learning opportunity. It's a way for you to say, okay, that happened. Maybe that might have sucked. Okay, how am I gonna get past this? And what am I gonna do differently next time? And it's in those moments that you have an opportunity to look at things and to grow as a human and as part of this community. Dive in and play around with technology. Continuous learning is super important as the world continues to evolve, whether it's ecology, whether it's engineering, whether it's pharmaceuticals, whether it's bats. Continue to play with things just to get to know them. And why do I say that? It gives you confidence to be able to learn anything. When I first stepped into my current role, and I said, you want me to talk about quantum computing to people who are building computer systems and needing to upgrade all of their business processes. And I was like, again, are you sure you have the right person? But I dove in, I rolled up my sleeves. I asked my team a lot of questions. They're the experts. I empower them. I read a lot of material online. It doesn't mean I'm an expert, but it means that I can speak to it enough to help people understand the importance of it. And the last thing is be uniquely you. So understanding that your quirks make you who you are and make you special. That's really important. I'm a nerd. I will put that out there. I love speaking to people. I love opera singing. I love hanging out with my cats, and that makes me uniquely me. And I know that I have a different perspective and a creative brain. You'll see that any of you might have seen my notes. It's kind of all over the place. But that's because that's how my brain works, and I embrace that. And so in closing, I hope that you have some things to think about and take away from today. I hope I've intrigued you about a career in cybersecurity and some of the cool things that you can be part of in this community. So whether you're interested in math, computers, engineering, physics, or any other science, the path you will take will lead you to interesting work. I can tell you that. I never thought in my wildest dreams that a girl from small town New Brunswick would end up leading a group of crypto mathematicians and the government and Canada at large on how to prepare for the quantum threat to cryptography. Please don't limit yourselves. You never know what lies ahead for you in your careers. And I can guarantee that as you progress, you will not regret some of the opportunities that will come your way. And even the failures you will learn to embrace. Thank you very much. I'm very happy to take any questions.
Thank you so much. So we have time for 2 questions. Who would be the 2 lucky ones? Wonderful, yes.
Hello, you're really cool, by the way.
I felt the same.
Hey, every scientist here is cool, but I've never, seeing a computer person is... Anyways, what's your opinion on quantum and nanotechnology?
Sorry, can you repeat that, please?
What's your opinion on quantum and nanotechnology?
Quantum and nanotechnology, in terms of the nexus of the two, or what specifically?
Just in terms of how do you think it's going to impact the future in science as we know it?
Great question. I'm going to speak at a very high level because I will admit I am not an expert in this field at all. But certainly, yes, it's going to impact everything that we do. When we think of quantum computing is just one element of quantum physics and science, right? There's so many opportunities that are going to revolutionize everything that we do. And nanotechnology is a huge part of that as well. So at a high level, we're going to have to see how things evolve over time. But again, the era that we work in right now and how technology is changing with physics and with quantum computers and other quantum sensing and other technologies, it's going to be a very interesting time over the next 10 years, is what I'll say.
Thank you.
Thank you.
Hi. So it's also really interesting to hear about you. And well, I have a similar question as well. So you mentioned about quantum computing and its impact. I'm really enthusiastic in quantum computing and quantum mechanics as well. So I was wondering, in terms of how would you face or how would you tackle in terms of quantum computing, in terms of cryptography? What are your plans in that?
What are the plans?
Yeah.
Great question. So right now, I mentioned cybersecurity is a team sport. So we work very closely with academics. I actually have some meetings this afternoon at the University of Waterloo with some of my colleagues there. So the government is preparing in a number of different ways. So there's the technology aspects, absolutely. My team works on upgrading the national security systems as well that we have that secure our most sensitive information in Canada. And so we're working with industry, with the private sector. We have a lot of vendors and technology companies that are developing products to help people think about what they need to do to start transitioning. One of my team members also participates in international standards communities for cryptography. So everything from the banking industry to self-driving cars, it all uses cryptography. And so there's a lot of work happening in the international standards community. If that's something that interests you, I encourage you to look at things like the IETF, ASCX9. There's a whole slew of things happening in the standards. That the research, which takes years in cryptography, informs the standards. And then once we have the standards in place, we recommend people use accredited, standardized technology. And so we'll be working with the vendors to ensure that is in place, that they have the proper certifications, and then people can start transitioning their systems in the next 2 to 3 years. We expect the standards to be in place by about 2024. And then we'll continue to be, I'll be out, you'll probably see me out everywhere talking about what we need to do as a community to get ready for the quantum threat. So I hope that answers your question.
Yeah, totally. No, that sounds amazing. I have this organization or platform that it's mainly on focusing on promoting more girls into STEM and quantum computing. It's called Girls in Quantum, and that actually makes sense with what you say. So thank you so much.
Thank you so much. Great question.
Thank you. So we have time for one more question, but before we get to that question, I would like to ask the speed mentors in the audience if you can exit the atrium just to get ready in your stations, and then we'll get to the next question.
Hi, so I think it's very impressive that not only do you focus on like science, but also music, because I personally love music, and my parents always tell me, choose one or the other.
Right.
So I just want to know, how do you think that music helps you be creative in your own field of study?
Great question. Sorry? You have to sing the answer. I have to sing the answer. Maybe after, we'll see. So for me, learning music and learning how to read music and break down, quarter notes, 16th notes, playing piano, all of those things, that helped me develop my logic skills. And that transcended very nicely into the world of computer science and IT. And so being able to have that, and so great question on the creativity. We talk about balance. I'm at work, I am in meetings nonstop, then I have to come back and I have multiple email systems that I'm trying to catch up on. It's very intensive, but my creative side, I go home and I sing. I still sing regularly outside. I learn new music, and that gives me the ability to be creative, to put my own artistic stamp on what I'm doing. And I think the two complement each other very well, right? When you think about solving problems, it's not always the answer is X. Right? Sometimes you have to meander your way to a different idea or perspective that will bring you to a different solution that's actually more comprehensive and better in the long run. And so I think embracing the balance of the creativity with the logic allows you to be that much more powerful and also communicating what you do longer term. So I hope that helps. It's hard to choose. I would say do a little bit of both as much as you can, and keep pursuing your passion.
Thank you.
Thank you.
Thank you so much for that fantastic answer. I do have to say, it's actually quite fascinating to see how multidisciplinary all the women that have presented today are. A lot of artists, a lot of connection to nature, connection to things that we sometimes don't stereotypically think about when it comes to science. So thank you so much for sharing. Thank you so much for your coming. Thank you. And now I would like to welcome now Lisa Hazenfratz, is the Executive Chair and CEO of Linamore. She's based in Guelph. Linamore is an advanced manufacturing company combining leading-edge technology with deep manufacturing expertise, and we welcome their ongoing support as presenting sponsor of this conference. Linda joined Linamore in 1990 and worked her way up from the ground floor, experiencing all aspects of the business, including running a machine, engineering, and operations management. Linda has earned multiple awards and recognitions and is actively involved in many professional organizations. Thank you so much, Linda, for being here today with us.
Well, thank you so much, and what a great opportunity for me to sort of wrap things up this morning. What an incredible morning. I just enjoyed so much every single one of your comments. Your advice for these young women was fantastic. So I've been busy up here taking notes, and I'm going to try and summarize some of what I heard today, because I think that it's really great advice for you. The first thing I wrote down is careers are a journey. And I think we heard that from like literally almost every one of these women. And for those of you who put your hand up saying that you're feeling stressed about making decisions about where you're going, don't leave that stress behind. Like, leave it on the seat when you walk out of this room, because you don't need to be stressed about that. Get comfortable with the idea that your life is going to take some turns, right? Some right and left turns. And what's really awesome is you learn something at each one of those junctures. And what, in the end, it makes you who you uniquely are, and you're uniquely qualified then to do the jobs that some of these women have talked about. So, I don't think you need to be so stressed about that. I agree with what a few people said. Study something that you love, that you're passionate about, that you're excited about. I 100% agree with that. I do also, being kind of a practical person, also do a little check to say, okay, I really love, studying this. What are some of the jobs I might do? What's the earnings potential of them? Shannon talked about the importance of lining that up, right? Because it kind of matters. If you have an expectation of a lifestyle here and a job that pays you down here, like, that's going to be a problem, right? So, and then you have a little path, and that may not even be the path that you end up on, and that doesn't matter, because, like I say, you learn at every juncture, but at least you have like a little bit of a line of sight to something that kind of makes sense for you, that there's jobs available and in an area you love, and then see where it takes you and see what you learn. And when you get into that program, whether it be university or college, I just think you're gonna find new things, you're gonna learn things you didn't even know about, and end up someplace really awesome. So careers are a journey. I think that's really important. Another important thing that a couple of people mentioned is the benefit of experiential learning, that it's not just about the theoretical stuff that you learn in school, whether it's college or university, but the hands-on stuff that you learn when you get out and work. And I think that's really great advice. Like, I really encourage co-op programs, summer internships if you're not in a co-op program, in something that is related to the field that you're studying, to kind of learn a little bit about what you like and what you don't like, right? Summer jobs and co-op jobs are very, not, you're not making a lifelong commitment. It's a 4-month commitment. So you can do all kinds of different things and experiment a little bit with different fields and different careers and see what kind of fits for you. So I think that was great advice as well. The third thing I would say is change is really happening in terms of the number of women in all of these different areas. And I think you heard a couple people talk about that as well. I think Vanessa mentioned something about how many more women there are in all these different areas. And I think that you're going to find that when you enter into your chosen area, if you do choose STEM or trades, you're going to find that there's a lot more women than you think. Even like I look at University of Toronto, one of the best engineering programs in our country is 40% women. 40% women in their engineering program. That is not a small percentage. That's nowhere near only person in the room. Like, things have changed so much over the last 20 years, the last 25 years, and I think momentum is building. So don't be afraid you're going to be the only one there. And if you are the only one there for some reason in that room or in that boardroom, then be bold. Like Melanie told you to, be bold and don't question whether you have the right to be there. You have the right to be there. You wouldn't have been chosen to go there if you didn't. And feel confident in your knowledge and your capabilities, that when you're in that room, you're there for a reason, right? You're there to talk about something. If it's a business, it's a meeting. You're there to talk about something. You're there for a reason. Get down to business and do it. And what I have experienced in my lifetime, because there's been lots of times when I was also in a room and I was the only woman, and I just did my job, and everybody kind of really fast forgot about the fact that I was a woman, I was whatever, I was young, whatever. Because after all, we're there to get something done. And if you just get down to it and you know what you're talking about, then that all kind of quickly goes away. I also really liked all the advice everybody had about dealing with stress. I think that's, I totally agree, such a big deal, especially today. It just feels like there's so much stress on all of us. And they talked about finding coping mechanisms and mentorship and communities that you can tap into. All of that is so important. Mentorship was mentioned a couple times as well, of how important it is to have somebody that you can look up to and that you can learn from. I think that's really important. In fact, at Linamar, I think it was 5 or 6 years ago, we started an initiative we call See It, Be It, STEM It. And it is an initiative to encourage more young women into STEM and trades through the use of role models. So we have a website. It's called seeitbeitstemit.com. I would love you to check it out. We have now close to 320 role models on our website in all kinds of different areas of STEM and trades. In fact, 2 of our speakers today are on our website, Shannon and Celina. I would love to have the rest of you on the website as well, because it gives you ideas for jobs. One of the questions somebody said, how do I know what kind of jobs? You can see all kinds of different jobs that you can do in all different areas of STEM, and hopefully find somebody that you can relate to in some way, that you have common interests, common backgrounds, whatever. And the idea is if you see it, you can be it too. So I encourage you to check it out. We also take 12 women off of the website every year and make a calendar that we can tell more about their story, get it into classrooms so that every month the students can meet a new inspiring woman in STEM. We have a stack of calendars outside, so I really would love you all to grab one on your way out and meet our role models for this year. Celina was one of in our very first calendar, in fact, role model, which was awesome. Last couple things. It's okay to fail. A couple people talked about that. I agree so much, and I love how you said, look for failure, because you learn so much from it. Failure is rarely fatal, right? And success isn't forever either. So, just because you're great at something doesn't mean you're always going to be, and just because you failed at something doesn't mean you're going to fail everything, right? Spend a day celebrating your success, spend a day mourning your failure, and then get on with it, right? Because it doesn't dictate who you are from here on out. The link between art, creativity, music, and STEM is very well defined. So anybody who tells you you're either science-y or you're artsy is totally wrong, okay? And that's something that we have so found in our See It, Be It, STEM It initiative. So many of our role models also have this huge creative side. They're musicians, they're writers. Two of our women are writers, have written books, children's books, singers, musicians. There's a huge link there. So don't ever think that you can't be creative, and science is all about creativity. It's about coming up with ideas. So don't feel like that's not true. So there you go. That's my summary of what I heard today. I was very inspired. I hope you guys were inspired as well. I am also a science grad. I have a degree in chemistry. Today I'm running a manufacturing company. Okay, not super related, I admit, but again, right and left turns, right? And find something that you enjoy that can lead to a path that kind of makes some sense for you, and then follow that path wherever it takes you. And I really wish you all the best, and I hope you enjoy the mentor sessions, the speed dating that's about to happen. I think it's an awesome way to learn about a whole bunch of different careers as well. And thanks for being here today. We're thrilled to be the presenting sponsor. Thanks.
Thank you so much, Linda. Wow, we have covered so much today. I hope you are as pumped as I am, I want to strongly encourage you to share your experience on social media. I want to see tons of tweets, I was going to say LinkedIn posts. If you have LinkedIn, I don't know. We'd love to see so many tweets, Instagram posts, even TikToks. Like, we'll see. Maybe you go viral at Perimeter. Who knows? So as we close, I want to thank again Linda so much for her participation today and for Linamar Corporation's ongoing support for women in science as presenting sponsor in this event. For our online audience, thank you so much for joining us. We really, really, truly hope you enjoyed this experience. Please join me once again in thanking all of our speakers and panelists for sharing their fantastic experiences today. Thank you so much. And I want to say, let's thank them once again. And